Hey guys, welcome back. So in the last video we had to stop kind of abruptly because we ended with what I thought could have been an HSRP bug with these Catalyst AKVs. Turns out I think it may in fact be a bug. I did a quick search and I found this bug ID. It's not necessarily it does say, excuse me, it does say that it affects Catalyst AKVs. However, the version that we're running, they claim that it's fixed, but it does not seem to be the case. So if we look here, I've played with two versions, and again, I think I showed this a couple videos back, but these are both the gold star releases at the moment. So they claim that this bug is fixed in these versions for the specific hardware that they make mention of, as well as the 8kV. But from what I'm seeing, that's not the case. So what I did to kind of prove it out was, if we go to our Internet Router 1, right, we have this configuration on our port channel 1901, right? We slapped our public address on there and we put a standby address on there. So what we had seen in the last video was, it seemed like one-way conversation. But if you go on the firewall, okay, the firewall this route is irrelevant for this because the firewall has an interface on that same VLAN, okay? So they share this subnet between them. So the firewall's .5, the router's 1, and we're trying, or excuse me, 2, and we're trying to simulate the VIP, which is .1. So check this out. If I ping 101.102, which is the router's raw interface, it works like a dream, okay? However, if I try to ping the HSRP address, it does not work. That tells me that there's definitely a bug with HSRP. These IPs are on the same subnet. There's no discrimination between 1 and 2 as far as the network goes. They sit on the same VLAN. So I got a workaround to kind of proceed with the lab and not let this kind of prohibit our progress, if you will. By the way, they tell you that if you clear the ARP table, that's a workaround. That does not work. I tried that. It does not work. So what we can do is we'll essentially we're going to shut down router 2, which is what I just shut him down because there's no point in having him in theory if we can't do HSRP with the design we're working through. If we introduce routing between all this stuff, then and forget about HSRP, we can certainly approach it that way. I wanted to do that as like a take 2 just to show you guys multiple ways of accomplishing the same thing. So whatever, we'll probably get to that at some point. But let's just get connectivity out to the internet, make this work so that we can kind of move on. So we're going to forget about router 2 for the moment. We're just going to focus on router 1, okay? So what we're going to do is we're going to come under this interface and we're just going to get rid of the standby, okay? So we're going to say no standby 1. So if we check him now, he's just nothing more than a plain Jane interface with an IP address on it. And it doesn't really matter. We can leave it at 2. It's irrelevant in my opinion. But we just have to make sure that our firewall has the correct route. See, right now we're pointing to 1, so we're going to want to change that to be 2. Okay? So let's get rid of that. Let's replace that with 2. All right. And again, we know that we can ping 101.102, so we should have no issues getting out to the internet. Let's just configure our NAT configuration while we're on the firewall. So if we show run include NAT, we can see we don't have anything. So let's go ahead and go under port channel 1.254. We know that that's going to be NAT inside, so let's tell it that. We know that 901 is going to be outside, so let's do that. Let's configure our access list. So we'll say IP access list standard We'll give it a name. We'll say NAT. What I like to do, I didn't really learn this from anybody. I just kind of came up with my own standard. But when I'm doing anything like an access list, a route map, a prefix list, anything that I have to provide a name for, I use all capitals. That's something you probably will hear from other people. But I always end it with dash and then whatever it is. So like if this was a route map, I would say RM. If this was a prefix list, I would say PL. In this case, it's an ACL, so I'll say ACL, okay? And the more stuff you start to configure in the config, the easier it is to spot this stuff. And a lot of times the way Cisco does it is these things are nested. So a route map's going to reference a prefix list. So when you're looking at everything, the name is the same. It's just the ending is a bit different. It just makes it, again, I use the terms easily identifiable. So we're going to say IP access list standard NAT ACL. We'll say permit anything that's 10 dot, okay? And then we'll go back and we'll do the long command, IPNAT inside source list. We're going to reference this. We're going to send it out interface 901, and we're going to go ahead and we're going to overload that, okay? So now if we show run include NAT, we can see that we have the inside, the outside, and the tie between the two, okay? So the firewall should be in a good place. And again, that should have no bearing on the ping connectivity. So if we go back up here and we ping, okay, it should be okay. Just for, let's do some housekeeping real quick. If we go to, let's say, Core 1. So we're going to come down a level. So let's go to Core 1. Remember, we should have, let's check Core 1 real quick. Show run include route. Okay, so we did prep this guy with the route, right? So we're basically just sending a default route to the firewall on that inside interface 254.5. So let's just do a couple pings to make sure that we still have connectivity to all of these IPs. So we can ping our next hop, which is the firewall, okay? Let's try to ping the firewall's outside address. So that was, let's just do a show IP interface brief. That should be this address here. So let's try to ping that. Okay, that's good. Let's try to go one hop further. Let's go to our new default gateway to the internet, or our default route to the internet, which is router 1, which is the .2. Okay, so this is where we're going to have to focus a little bit of time to make sure that this is obviously working, okay? So there could be a misconfig, there could be something going on there, right? So we'll have to visit that at some point. So it looks like, did we show include route? Let's just make the firewall, make sure the firewall can ping back. Okay, he can. So that's the HSRP VIP, and that's funny, right? So the bug claims the HSRP doesn't respond on a sub interface, which is exactly what we were trying to do between the routers. In this case, this is an HSRP address, but it's going to an SVI or an interface VLAN, and it works. So again, that just reinforces the thought in my mind that this is most likely a bug. At any rate, on the... Yeah, so we'll have to come back to that. And just to see, we're probably, because we didn't really get too much in the routing, I was just trying to kind of verify connectivity before we jumped up to the internet side. So let's look at internet 1. And if we show IP BGP summary, remember we have our neighbor, which is ISP-A. However, we're not learning anything. And we shouldn't be advertising anything either. Because if you recall, we just had a very basic configuration of BGP. So ultimately, we know that we're going to want to advertise the 101 subnet space. Okay, so we know we're going to want to advertise 101, so we may as well just stick that network statement in there now. There's no reason not to, okay? So let's come under BGP, under the address family, and we'll say network, and we're going to say 101.100 with a mask of /24, okay? So that essentially tells the rest of the world what IPs the Cisco DC1 wants to advertise, okay? So that should do it. If we come over to ISP-A and we show IP BGP summary, we can now see that we're learning a prefix, and if we show IP BGP, look at that, we now know about Cisco's /24 subnet, so that's good. All right, so that, and it should stick it in the routing table, okay? At some point, it may still be thinking. So it didn't mark it as best yet. Oh, you know why? Hold on. Let's get rid of this. No to that. Let's show IP route. Okay, much better. So it injected this route into the routing table. It's been in there for 3 seconds. So that tells me that it learned about the route from Cisco's data center. It marked it as best, which we should see with this asterisk. So it is valid, right? It marked it as best, which is the, you guys want to call it an alligator mouth, whatever you want to call it. That is the the verification that that route is good, and it's been placed into the routing table as a BGP route. So far so good. Now, how do we get, if we go back to our router and we show IP route, let me get rid of the static route because we don't want a static route. We want to leverage BGP, okay? So what we should see is nothing more than connected routes, okay? So that's everybody's starting point is obviously the routing table is empty until you populate it with something. We know that we're only advertising our routes to the service provider, but we're not learning anything from the service provider, okay? So we see that we're not learning anything. So the service provider, let's just do a quick homework piece here, or housekeeping. So it should be the service provider's job to advertise the link between us and them. Okay, they're the ones providing us that IP information. When we call and we say, hey, we want a 1 gig circuit or whatever through you guys, they're going to provide us that IP information. We're not coming up with that, they are. So it's their responsibility to tell the rest of the world about this link, okay? And chances are this link is going to be carved up from a space that they own. So we're going to go ahead and we're going to put that advertisement on the ISP-A because, again, that's typically their responsibility. We normally don't have to worry about this, but in the case of a lab environment, we need to handle that some way. So I'm going to put that under BGP for the service provider. So if we come under the address family, we're just going to say network 201.110.0, and we're going to say /30. There's a caveat with this in real life. The BGP table, the global BGP table, you're not going to see anything that's smaller than a /24. It's because the size of the BGP table is very large, and if they started to allow masks that were smaller than that /24, it would just probably blow the routing table up, honestly. So in this case, it's a lab, so we don't necessarily care. All right. That should not. Okay, so it did. Show IP BGP. So now we can see that we learned a /30 from the ISP. Okay, that's a result of this statement that we just put in. Okay, However, I'm building this up because the end goal is that if we show IP route, our internet router has no idea how to get to anything else besides what it has connected to it, okay? It didn't install this prefix, by the way, because we have a connected route for it. So the connected wins as far as a administrative distance over the BGP. So that's why you don't see a BGP route, because we have a better route, which is connected, all right? Ultimately, what we want to do is most likely get some kind of a default route from the service provider, okay? If, generally speaking, you're not going to want to get a full BGP table from your service provider, because if we look at our topology, we only have one way out in this case. We've shut down router 2, ISP-B is irrelevant for right now. There's only one way to the internet, so why would I need to know about a zillion routes to get to the internet, right? I only care about one exit point. So generally speaking, you just tell the service provider, just advertise me a default route. That's, I'll say, maybe 8-9 times out of 10, that's typically what you'll see. There are exceptions. Like I said, there always are exceptions. But we're going to follow suit, okay? So what does that look like? How does the service provider do that? If we come over to ISP-A and we show run section BGP, what we're going to do is we're going to come under BGP and we're going to hit the question mark. And the one that we're going to want to concern ourselves with is this one. You'll learn about the default information command, and this is something that's used for all the protocols. So it's not just BGP, you can do this with OSPF, EIGRP, etc. So let's put default information and let's hit the question mark. It says there's a keyword called originate. It says distribute a default route. Well, that is exactly what we want to do, right? We want to provide our customer, in this case Cisco, with a default route. So we're going to put that under the BGP configuration. So we can see that that is now under the BGP, specific to our customer, right? Now let's see if that did anything. So let's show IP route. Okay, we still don't have a default route. Let's check our BGP table. Not seeing anything. Let's clear BGP just to speed this process up, just to make sure we're not missing anything. Still not seeing anything, right? Nothing. We're only seeing the one prefix, which was that 201, okay? This one here. So what we did on the ISP wasn't enough. So there must be more to the picture, okay? So let's check the ISP's table. His routing table. Show IP route. Well, he doesn't even have a default route. So that's interesting, right? So maybe he needs to have a default route in order to advertise a default route. Well, then you might ask yourself, well, where do we point the default route for ISP-A? In this case, it's a triangle. Like I don't necessarily want to point them to the loopbacks. I maybe don't necessarily want to point them to ISP-B. So where do I point a default route? There's a little trick that you can use. Okay, so if you do IP route, we're going to say quad 0, and if we hit the question mark, there is a keyword for null. Okay, this is just a trick that we can use. We can point a default route to null 0, which is kind of nowhere, if you will. Okay, but all we're trying to do is essentially fake out the table to say that, hey, we have a static default route, which now we do, okay? Let's see if that triggered anything on our internet router. So let's clear IP BGP star soft, and then we'll show IP BGP summary. Man, we still don't have a route. Still not enough, right? Nothing there. There's one more piece that I believe we have to do. So if we go back to BGP, so let's come back under BGP1. Let's go here. and let's tie a network statement to that quad 0. So let's say network 0, 0, 0, 0. So what we did was we introduced a static route for quad 0 that we pointed out to our, some people used to call it the bit bucket, but the quad 0 points out null 0, right? And then all we did was then we said, okay, now advertise it with the quad 0, all right? And this is the command that says advertise the default route. So there was 3 pieces that we put in. Let's see if that was enough. Let's clear IP BGP star soft. Show IP BGP summary. Hey, look at that. Now we've got a second prefix. So what is that second prefix? Wouldn't you know, it's a quad 0 route. So did it make it into the table? It sure did. So now we have a quad 0 route we learned from BGP, okay, which will basically get this router full connectivity to any destination on the internet, you would think. So let's just test that theory out. Let's go ahead and let's get on the loopback box. So he's brand new, he has no configuration. Okay. All we're going to do here is we're going to just build a quick peering between ISP A and loopback, and then we're going to just define our 8888 and 4222, and we'll see if we can get reachability from Internet Router 1 up to the loopbacks, right? That's the end goal. So it looks like gig 2 links the 2 routers together, right? So we're going to do hostname, INET, loopbacks. We're going to go into interface gig 2. We'll no shut it. We'll just give it some really lame fake address. We'll just say, let's put this guy over here. And let's go to ISPA, show IP interface brief, interface gig 2, no shut. So we'll do IP address 1.1.1.1 for him. We'll make it a /30. Oops. We'll give this guy 1.1.1.2. We'll make it a /30. Just make sure we can ping one another. Okay, so we got connectivity. Now let's just do a quick peering. So neighbor 1112 remote AS. What did we say? We said ISPA gets BGP1, ISPB gets ASN2, and the loopback's going to get ASN3. Oops, sorry. So he's remote AS3, right? And then we'll just go ahead and we'll activate him. All right, good. So do show run section BGP. Let's just get we can advertise this network from either peer at this point. So we can put it in both. So let's go under address family IPv4. We'll say network 1.1.1.0 mask /30. Okay, and then now we have to do BGP all together over here. So we got to say router BGP3. Okay, we're going to do neighbor 1.1.1.1. He's in remote AS1. We'll go ahead and we'll activate him. We'll go under the address family and we'll say network 1.1.1.0 /30. Okay. While we're in here, let's just get the network statements for our loopbacks that we're going to build. And again, I'm breaking all the rules here with BGP because I'm doing /30, /32s, all this stuff. It's a lab, so it's not as important. I just want to prove reachability and build a routing table, right? So, I mean, I guess we could do mask 255. We could do something like that. This should work. Yeah, I don't know. It's not going to like that. So, we'll have to say 8000. There we go. And then for interface loopback 0, we'll have to say 8888 255000. That should be acceptable. So we gave it a specific IP, but we told it was a /8, right? And that's the way the network statement has to read. So let's just see, did that get injected over here? So he learned it, right? Do ping 8888. Okay, good. So he learned it. Did this guy learn it? Show IP route. Yeah, it looks like he did, right? So he now has a route for 8. So if we ping 8888, it looks like it works. If we trace, let me do no IP domain lookup. Trace. Okay, good. So now we can see we can do trace routes. We went through ISP-A, who has autonomous system number 1, and we were able to essentially get to 8888. We can play with it more if we wanted to. So if we come back to the topology, we can kind of like force traffic over to B. Like once we get B involved, right, and we have a full mesh, as we say, we can shut down this link between A and loopbacks. Right, and then when we do that trace, it should route through B to get there. So we can play around with all that stuff. But for the time being, right, like it looks like we have, kind of simulated some internet access. So if we come back to, so this routing table, got a little bit bigger. We've now got the default route to the internet, right, that we learned through our ISP. We have introduced some loopbacks. Let's go ahead and do 4222 while we're at it, right? Interface loopback 1, IP address 4.2.2.2, and we'll do the same thing. We'll make it a /8 just to kind of make it a bit more realistic. And then under BGP, we'll go ahead and put that in there. Network 4.0.0.0 mask. And see what it did there? When we're typing the mask, that it kind of knows that that's a class A, right? It should recognize that, so when you verify it in the config, it strips the mask out. So see that? Versus this one, it leaves it in there, right? I just want to point that out. So now if we go show IP route, we now have a route for the 4 dot. If we come over to here, show IP route, we can also see that, right? Now, if you might be asking yourself too, like, the service provider's advertising us the default route, which we said was to kind of save the resources of the routing table, but now we're still learning all the other garbage routes, right? So why are we learning these routes when all we really want to learn is this? We have to, we can start to introduce some route filtering, okay? So, why don't we do this? We'll take a break here, right? And in the next video, we'll basically, I love how the server keeps moving himself way over here. In the next video, what we'll do is we will introduce some route maps, okay? So we'll practice with route maps. we'll attach the route map on the inbound direction from our service provider, and we'll basically tell that route map that we only want to accept the default route. So when every time an internet route gets added to the table, right? So like we added 4, we added 8. We don't necessarily need to know about those, right? We've already got a static default that we learned. That's enough. We don't need to know these more specific routes. So we'll introduce that filtering through a route map. That'll be a good demonstration. We will verify connectivity from our servers all the way up to the internet. So we'll figure out what the problem is between one of these devices. We've got something going on where that routing is not working. So we'll go ahead and we'll nail that down. And that should essentially give us a full build out for the data center up to the internet. And then eventually, the next logical step is to introduce the WAN, right? So we've got the Cisco sites that are just able to talk to one another. Now we have to incorporate their access back to the data center. So we'll do that probably 2 videos from now. That's going to be where we land. So I hope this is worthwhile. Like I said, thank you for any and all time you spent with me through this process. You know, like I said in the beginning, we had some adversity through some bugs and some issues, but we're working through it. We're trucking along. So I hope to see you guys on the next one. See you there.